Welcome to the lecture number 57, dear students. We have studied three theorems in the last lecture. That tangent is always perpendicular to the radius at its point of contact. Second theorem, if any segment is perpendicular to the outer end of the radius, then it is tangent to the circle. And third theorem, we studied that the tangents drawn from the same external point to the circle are always common. So, on the basis of these three theorems, we are going to solve the sums from exercise 3.1. So, in exercise 3.1, you will find circle is given and this is tangent to the circle, and on the basis of this some questions are asked. I am going to write that. So first one, what is measure of angle CAB? Angle CAB is equal to angle CAB is 90. Reason is also asked. So CAB is equal to 90. Reason is tangent radius here. Tangent radius here. Second one. What is the distance of point C? What is the distance of point C from AB? What is the distance of point C from AB? Now you find distance is equal to the radius, and while finding out the distance, we always find out perpendicular distance. Therefore, this distance of point C from line AB is 6 cm. C is equal to 6 cm. Here even you can mention that line AB is perpendicular to CA. Third one is distance AB is equal to 6. Distance AB is equal to 6 centimeter. Find BC. Find BC. We have to find out BC. So I am going to join BC now. If I join BC, dear students, you will find they have given us the distance AB as 6. We have to find out BC. You will surely notice triangle CAB is a right angle triangle. So we can apply theorem of Pythagoras. So, triangle CAB, this is answer of 3. Triangle CAB is a right angle triangle. Is a right angled triangle. Therefore, by theorem of Pythagoras, you all know theorem, hypotenuse square is equal to sum of the squares of remaining sides. So BC square is equal to AC square plus AB square. AC square plus AB square. Now value of BC we have to find out, but we know the value of AC as well as AB as 6 centimeter. So that is equal to 6 square plus 6 square. That is equal to 36 plus 36. Value of AC as well as AB is 6 each. 36 plus 36 is 72. 36 plus 36 is 72. Therefore, BC is equal to root 72. Root 72 is equal to 36 twos are. I split 72 as a product of one of the perfect square number, and that is 36. So you will be getting square root of 36 is 6, root 2 centimeter. This is value of BC. That is what we have to find out. That was our question number, sub question 3 of question 1. Then one more question is there. Please try to listen. The next question is, what is the measure of angle ABC? What is the measure of angle ABC? This is fourth question, fourth sub question of question 1. What is a measure of angle ABC? Angle ABC is equal to how much? So in the adjoining figure, the radius of a circle is saying the C is 6 centimeter. Answer the following. Now we will find, we have to give the answer of angle ABC. If you will think with reference of this question, then you will find these two are congruent angles, and these angles are 45 each. Because if AC is 6, AB is also 6. The triangle CAB becomes isosceles triangle. So angle ABC is equal to 45 degree. But still I would like to verify the given answer in the textbook. Yes, it is 45. Reason is triangle ABC is an isosceles triangle. So this is how we finished here. Question number 1. There are 4 sub questions in this question number 1, and we finished it. Now let's begin question number 2. Question number 2, exercise 3.1. Now you will notice, dear students, figure 3.20. Please refer to the figure 3.20. It is easy question. First of all, I am going to draw a figure. Here there is point R. From point R, two tangents are drawn to the circle. R N O R. O is the center of the circle. Here two points are given, namely points M and N. I am going to join these all and O as well as ON. ON as well as ON. M and N are there. You all know, dear students, angle N and angle A are 90 each by tangent radius there. Now let's see what is given. Question 2, figure 3.20. In the adjoining figure, O is the center of the circle. From point R, segment Rn and segment Rn, two tangents are drawn. Next to that, these are touching to the circle at points M and N. If OR is 10, and radius of circle is 5, then what is the length of each tangent segment? What is the measure of angle NRO? As well as what is the measure of angle NRN, NRO as well as NRN. Please have a look at this question. So first one is find MR. Question is find MR and NN. Since you all know, dear students, tangents drawn from the same external point to the circle are always congruent. Therefore, if we find out Rn, then there is no need to find out Rn because they are congruent. Now, triangle O and R is right angle triangle. So, answer triangle OMR is a right angle triangle. Is a right angled triangle. Angle N is 90. Tangent radius 10. In triangle OMR, since you all know this is 90 degree, OR is opposite to 90 degree, therefore OR is hypotenuse. Therefore OR is hypotenuse. By theorem, of Pythagoras, OR square is equal to ON square plus MR square. ON square plus MR square. Value of OR is 10. So 10 square is equal to 5 square plus MR square. Since you all know 10 square is 100, if I transfer square of 5 as 25 to the left hand side, I'll get 100 minus 25. It is very easy. 75 is equal to MR square. Since we have to find out value of MR, root 75, taking square root from both sides, square root of 75 is equal to MR. I can write 75 as 25 threes are. That is equal to MR. But since you all know, square root of 25 is 5. So we'll be getting 5 root 3 centimeter is equal to MR. This is how we obtain value of MR. But you also know tangents drawn from the same external points are always congruent. Therefore, MR is equal to RN, MR is equal to Rn, and that is equal to 5 root 3. 5 root 3. So question asked is the same, that what is the length of tangent segment? Next to that, what is measure of angle MRO? Please try to understand. We have to find out this angle. You will notice, dear students, This is hypotenuse, which is 10, and this is ON is 5. So 5 is exactly half of the hypotenuse. 5 is exactly half of the hypotenuse. So second question here, sub question, you can say, what is angle NRO? What is angle NRO? So you can say here, since ON is half the hypotenuse, ON is equal to 1 upon 2 OR. For your convenience, I am writing in bracket hypotenuse. Therefore, by converse of 30, 60, 90 triangle, by converse of 30, 60, 90, angle NRO is 30 degree. Angle NRO is equal to 30 degree. Now next question, next sub question, I would say, what is the measure of MRN? We have to find out this whole angle. Third sub question, what is angle NRN? You will find these two triangles are congruent by hypotenuse side theorem. So you will be getting triangle ORN is equal to triangle ORN. These two triangles are congruent by hypotenuse side theorem. So angle MRN is equal to 60 degree. We must mention over here triangle OMR congruent to triangle ONR by hypotenuse side theorem, and therefore these two triangles are congruent. If these two triangles are congruent, their corresponding angles are also congruent. Therefore, we got this as 30. If this is 30 and this is 30, we'll get total angle NRN is 30 plus 30 as 60. That is what is written over there. So this is how you will find we finished. Question number 2 of exercise 3.1. Please have a look at this sum carefully. Hope this sum is very clear to you. I am going to do now third question of this exercise 3.1. Exercise 3.1 is given on page number 55. I request you, dear students, while watching this video, please keep your textbook in front of you so that you will understand the figures given in the textbook. So now question number 3. In question number 3 also, figure is given. O is the center of a circle. R is any point outside the circle. R is any point in the external of the circle. Then from point R, Rn and Rn, two tangents are drawn to the circle. Name of the two tangents are Rn and Rn. Two tangents are drawn to the circle. So this is Rn, and you will find second tangent is Rn. On and On are joined. So I am going to join now On as well as On. This is how we complete the figure. Figure is 3.21. I am reading this question. Rn and Rn are tangent segments of a circle with center O. O is a center of a circle. Rn and Rn are tangents drawn to the circle from point R. Prove that OR bisects angle NRN as well as angle NON. So I am going to label this as X and Y. If I label this as X, this as Y, this as Z, and this as W. In the previous sum only, I have explained you, dear students, these two triangles ONR and ONR, we have to prove congruent. Okay. So you will find, to prove that, since I have labeled it X and Y, I'll write NRO angle NRO is congruent to triangle angle NRO. I write over here angle X is congruent to angle Y. Also, we have to prove angle MOR, is congruent to angle MOR. Bisecting means to dividing to give an angle into two congruent parts. So since I have labeled them as Z and W, I am going to prove these two triangles are congruent, and after proving them these two triangles congruent, I will also prove X is congruent with Y, corresponding angles of congruent triangles. Z is congruent to W, corresponding angles of congruent triangles. So let's prove these two triangles, namely OMR and ONR, congruent by test. Now you will also notice these two triangles are even congruent by SSS test also, because tangents drawn from the same exterior points are congruent. OR is a common, ON and OM are radii of the same segment. So you can prove these two triangles congruent by hypotenuse side theorem or by side test of congruence. So it is your choice. Both the methods are correct. So you will find, now I am going to begin proof here. In triangle, ONR and triangle ONR. Triangle OMR and triangle ONR, OM to OM, radii of the same circle, radii of the same circle. Next point, hypotenuse OR, is congruent to hypotenuse OR, that is common. Angle M is equal to angle N is equal to 90. Tangent radius theorem. So hypotenuse OR is congruent with hypotenuse OR. If you have to call OR as hypotenuse, you must have to mention angle N and angle A are 90 each. Otherwise, if you simply mention OR is congruent with OR, common, in that case you have to use side test. But if you are going to prove this by hypotenuse side theorem, then it is must to mention N is equal to 90. Therefore, triangle OMR is congruent to triangle ONR by hypotenuse side theorem. Since you all know, at once two triangles become congruent by any test. So their corresponding angles are also congruent. Therefore, x is congruent with y and z is congruent double. The reason for these two is corresponding angles of congruent triangles. So this is how you will find we have to prove that OR bisect angle MON. Bisect means to divide the whole angle into two congruent parts. Bisecting means to dividing the whole angle into two congruent parts. Therefore, OR bisects angle NRN and angle NON. Very simple sums of exercise 3.1. So last question of this exercise. Last question of this exercise 4. Fourth question is there. What is the distance between two parallel tangents of a circle having the radius 4.5 centimeter? Justify your answer. This is a circle I have drawn. Two parallel tangents I am going to draw. These are parallel to each other. Reason is very simple. These are parallel to each other. L is parallel to N. L is parallel to N. O is the center of the circle. This is P. This is Q. 4.5. 4.5. So distance PQ is 9. Very simple answer. But we have to give justification for our answer. Angle P plus Q, angle P is equal to Q is equal to 90. Tangent radius there. Tangent radius there. Then you will find OP is equal to OQ. Radii of same circle. You may write OP is equal to OQ, that is 4.5 centimeter. Therefore, PQ is equal to 4.5 plus 4.5, that is equal to 9 centimeter. Therefore, distance between two parallel tangents, two parallel tangents is 9 centimeter. So dear students, you will find this was the last question of exercise 3.1. Angle P is equal to angle Q. It is 90 tangent radius there. OP is radius. OQ is radius. 4.5 plus 4.5 will give us total length PQ. That is 9. Here that is justification. Justification is very, very important. To write all these things, P is equal to Q is equal to 90, tangent radius there, OP is equal to OQ 4.5, radius of the same circle, PQ is equal to 4.5 plus 4.5, that is 9 centimeter. Therefore, distance between two parallel tangents is 9. That's all for this lecture number 57. We are so finished. Exercise 3.1. Thanks a lot for listening as well as watching this video carefully. Praying to all of you. God bless you all. Thank you.